Okay, limiting reactants. What we have to understand here is that this is the reactant that's going to limit how much we get in our products. Okay, so limits the amount of product that can form. So really what happens is it's what stops the reaction or limits the reaction. When we run out of this reactant, then there's nothing else to react and we have to stop. So there won't be any more product. The excess reactant then is the one that's not used up. So this is the one that's left over. There's extra. So there's always going to be one reactant that's all used up, one reactant that we have extra of. And so here's our example. We want to find out which one is the limiting reactant in this reaction. So it tells us we're starting with this much of our N2H4 and we're starting with this much of our H2O2. We've got our balanced equation here, and so we just start by converting to moles. We look here, we use comparing moles, not converting, they're already in moles. So we look, we've got 0.75 moles of our first reactant. It does not really matter which one you pick. And then all we're doing is comparing the two reactants together. We've got 2 H2O2 for every 1 N2H4. So that's what we put here. We know that our mole of N2H4 has to go here because we want that to cancel out. And then we have 2 moles of our other reactant, which is what we're trying to solve for. So we do our multiplication, and this is how much we need of our other reactant. Well, if we look, we only have 0.5 moles of our other reactant. If we start with this much of our N2H4, we need 1.5 moles of our H2O2. We don't have that. We only have 0.5. So we know that our H2O2 in this case is our limiting reactant. It's what we're going to run out of. So how much is in excess? Well, what we do then is we just figure out how much we have extra. Okay, so we look here. This is how many moles of H2O2 that's going to allow us to run the reaction before it stops. So now if we do our 2 to 1 again, this time our H2O2 is on bottom because we want that to cancel out, and our 1's on top, so we're going to divide this by 2 and get 0.25 moles. So this is how much we'll actually get when we run the reaction, because you always have to start with your limiting reactant because that's what's going to stop your reaction. Well, we started with 0.75 moles, we made 0.25 moles, so that means we're going to have 0.5 moles left over. So that's our excess, that's our leftover. Now if we go back, sorry for the scrolling here, and look at one more, here we've got 2 moles of our hydrofluoric acid exposed to 2 moles of silicon dioxide. What's the limiting reactant here? Oops. So if we look at that, very similar to the other equation we did, we have to look at our mole ratio. Okay, if we have 2 moles of HF here, we have to put our 4 moles from our equation down here on the bottom of our HF, so these will cancel out. We're trying to get to silicon dioxide. We only have 1 mole of that, so that's what goes here on the top. We're going to take 2 divided by 4, and we get 0.5 moles of CiO2. So if we look back up here, we had a ton of this. We had 4.5 moles. 4.5 moles. We're not going to run out of the SiO2. We get 0.5, or need 0.5, excuse me, and we have 4.5. So this time what we're going to run out of is our HF. We're going to use all 2 moles of that. We won't run out of the other, and so that's going to be our limiting reactant, is our HF. Silicon dioxide we have plenty of. So these are how we run through our limiting reactant problems. Once in a while you will have to you'll be given something in grams, and so this first step here, where there's moles, you'll have to convert to grams first. So because the only way we can compare 2 different reactants is when they're both in moles. So just remember that if you're given your reactants in grams, you'll have to convert to moles first.